Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, my name is Jenny Sebisa Putri with NPM 2341171 from Class Management 23C. So in this second video, I will tell you what is probability. So the first thing I will tell you is what is probability. So basically, probability is a way of measuring and understanding uncertainty by quantifying the likelihood of events occurring. It answers questions like how likely it is to happen. For example, when flipping a fair coin, there are two possible outcomes, heads or tails. Probability helps us understand that each side has an equal chance of showing up. So if you flip the coin many times, you would expect heads or tails to occur roughly the same number of times. In any random situations, probability gives us a way to assess the chance of different outcomes. For example, when rolling a 6-sided die, we know that each of the 6 faces has an equal chance of landing face up. While we can predict the exact result of any individual roll, probability tells us that over many rolls, each number has the same likelihood of appearing. This is helpful when trying to make decisions or predictions in uncertain situations like weather forecasts or predicting the outcome of a game. Probability can be used in situations where the chance of an event is influenced by other known factors. For example, if it's raining, the probability of someone carrying an umbrella is higher. This is called a conditional probability, when the likelihood of an event depends on the occurrence of. And the second one is the factors of probability. The first factors is sample space. The sample space is the set of all possible outcomes of an experiment. The size and nature of the sample space play a crucial role in determining probabilities. For example, when flipping a coin, the sample space is head, tails, and head, tails, and there are only 2 possible outcomes, which makes the probability of each outcome is half. In contrast, if you're rolling a 6-sided die, the sample space is, and each outcome has a probability of 1.1 out of 6. The structure and number of outcomes is the sample space directly affect calculating a probability for any event. The second factor is equally likely outcomes. Probabilities are often based on the assumption that all outcomes in the sample space are equally likely. This means each possible outcome has the same chance of occurring. For instance, when drawing a card from a well-shuffled deck of cards, each of the 52 cards has an equal probability of being selected. In such cases, the probability of an event is calculated as the ratio of the number of favorable outcomes to the total number of outcomes in the sample space. However, in many real-world scenarios, outcomes are not equally likely. For example, when rolling a biased die, some faces may have a higher chance of landing than others, so the probabilities will need to be adjusted accordingly based on observed frequencies or known bias. And next is independence. The independence of events is another key factor in probability. If 2 events are independent, the occurrence of one event does not affect the probability of the other. For example, flipping a coin and rolling a die are independent events. Getting head on the coin toss does not change the chance of rolling a 3 on the die. When events are independent, the probability of both events occurring together is simply the product of their individual probabilities. In contrast, dependent events are those where the outcome of one event affects the probability of the other. For example, if you draw 2 cards from a deck without replacement, the probability of drawing a specific cards on the second draw depends on the card you drew first. And next is conditional probability. Conditional probability refers to the probability of an event occurring given that another event has already occurred. This factor is crucial when events are not independent. For example, if you know that it is raining, the probability that someone is carrying an umbrella increases. This is a conditional probability because the likelihood of carrying an umbrella depends on the condition of rain having occurred. The concept of conditional probability is used to revise our expectation when new information becomes available. And then there's the law of large numbers. The law of large numbers is a principle in probability that states that as an experiment is repeated many times, the observed relative frequencies of outcomes will get closer and closer to the true probability. For example, if you flip a fair coin a small number of times, their proportion of heads and tails may vary significantly. However, if you flip the coin thousands or millions of times, the proportion of heads should approach 50% as predicted by probability. This factor highlights the role of repetition and sample size in determining probabilities. Next is probability distribution. The probability distribution describes how probabilities are spread across different outcomes for a random variable. For discrete random variables, the distribution is represented by a probability mass function, as known as PMF, which assigns probabilities to each individual outcome. For continuous random variables, the distribution is represented by a probability density function, as known as PDF, which gives the likelihood of outcomes within a specific range. Understanding the probability distributions of a random variable is essential for calculating expected values, variance, and for making predictions about the behavior of random systems. And next is key concept of probability. Probability is built around several key concepts that help understand and measure uncertainty in random events. The sample space is the set of all possible outcomes of an experiment, such as the possible results of a coin toss. An event in any specific outcome of set of outcomes from the sample space, like rolling an even number on a die. The probability of an event is a number between 0 and 1 that indicates how likely the event is to occur, with 0 meaning it will never occur and 1 meaning it will certainly occur. Another important concept is complementary events, which represent the opposite of an event. And next, we move to the example. The question is, a courier works for a delivery company that handles the types of deliveries, delivery A and delivery B. The company's data shows the following: 60% of all deliveries are delivery A and 40% are delivery B. For delivery A, 90% of packages arrive on time, and delivery B, 80% of package arrive on time. The question is, if a package arrives on time, what is the probability that it was delivery A? And the solution is, this problem can be solved using Bayes' theorem. We want to find the probability that the package is delivered. We want to find the probability that the package is delivery A given that it arrived on time. P times A divided T, where A is the event delivery A and T is the event on time. Bayes' theorem states as PAT, PTA, PA, PET, where the PTA is the probability that the package is on time given its delivery A, which is 90% or 0.09. PA is the probability that the delivery is delivery A, which is 60%. PT is the total probability that a package is on time, which can be calculated using the law of total probability. The step 1 is calculate the PT. The total probability that a package arrives on time can be calculated by assuming the probabilities of the package being on time for each type of delivery. As you can see, that's the formula, and we have to substituting the known values based on the questions. Now calculate the PT. And step 2 is calculate P times A divided T. Now we can calculate the conditional probability. And the interpretation is if a package arrives on time, the probability that if it was delivery A is approximately 62.79%.